So I've been given a challenge, and that is to write a program using Python to determine if a number is a happy number. So what exactly is a happy number? So in number theory, a happy number is a number which eventually reaches 1 when replaced by the sum of the square of each digit. So as an example, if we take the number 13. So if we take the sum of the square of the digits, so we've got 1 squared, so that's 1, plus 3 squared, which is 9. Then we have 10, which would be 1 squared plus 0 equals 1. Okay, so that's a happy number. All right, so let's look at a way that we can code this. Now, by the way, I'm using Google Colab to code this. Colab is wonderful for Python development. Technically, it's something we call a Jupyter notebook. Jupyter notebooks are very, very powerful, particularly for people that want to combine text with programming. So you could theoretically write like a textbook in here. Because you can display text, you can display programs, you can display like equations, things like that. It's quite a powerful tool. So we have two different kinds of cells or blocks. So this is like a text cell, and then we can go ahead and we can also put in a coding cell. So I could start to write a program in this block here, and then I could have that followed by another text cell, right? So very powerful for demonstrations. Okay, let's first demonstrate this with the number 13. So I'm just going to go ahead and I'm going to add a coding cell. So let's put 13 into a variable, which we would call n. So a variable, think of a variable as like a mailbox, and on the side of the mailbox it's got n. It's stamped n. And if we look inside that mailbox, it's got 13. And the mailbox is reusable, so we can take 13 out and we can put something else in, right? So it can be reused all the time. So we've got this variable called 13, or sorry, variable called n, and in it is the number 13. So what I want to do is I want to basically iterate through that number. So I want to extract the 1 and square it, and then the 3 and square it. So how can we do that? So Python is really good at parsing what we call iterables. So if we have like the name Peter, that would be the P, the E, the T, the E, the R. So it's very easy to do that. So if I have a variable called name, and in it says Peter, okay, then what I could do is I could say for character, so I'm just going to call that C, in name, print C. And if we run that, look, I get the P-E-T-E-R. So instead of name, if we have n for number, so let's actually call that num. Sorry about these pop-ups, it's a real nuisance in Colab. So num equals 13. And then if we want to iterate that, okay, so for C, and I'm not going to call it C, I'm going to call it digit. Okay, and let's see if that works. Okay, so we get this type error. It says int object is not iterable. Well, what does that mean? Well, that's because num is an integer, it's not a string. So the first thing I need to do is convert that. So let's go ahead and convert num right here. So I'm going to convert that to a string. Okay, and now let's run it again. And now that works. We get 1 and 3. So that was able to extract the individual digits. So now we don't want to print digit. We want the digit squared. So 2 asterisks in Python is power. So we've got 2 there because we want to square it. So let's go ahead and run that. Aha. Well, we can't do that because the digit now is a string. So that's not going to work, so we need to convert this back to an integer. It's getting a little complicated, eh? Now that works. Okay. So instead of just printing them, we want to sum them. All right, so how can we do that? So let's add another variable. Let's call it sum. Let's initialize that to 0. And then as we step through the characters, we don't want to print them. We want to add them to that sum variable. So I'm going to say sum equals whatever the sum used to equal plus the digit squared. So in math, for math teachers, this is going to look kind of weird because you've got sum on both sides of the equation. But in programming, it's perfectly allowable. So what this basically means is it takes whatever sum used to equal, and the first time it equals 0, and then it's going to do the addition, and then it's going to stick that value, okay, into sum. And then the next time it runs, of course, that's going to be here. Okay, so let's see what we get now. When this is done, let's print the sum, and that's 10. Okay, so that seems to be working for us. Now, we want to take this one step further because now the new number, of course, is 10. And that's going to result in 1. All right, so let's somehow turn this into a loop. Let's turn this into a loop so that we can make this work for us. Actually, first let's turn this into a function that just takes the sum of the squared digits. All right. So to create a function, we use the def keyword, define. I'm going to call this function sum of squares. Kind of makes sense. We want to use something usable. And then we indent that. Okay. And in our definition of sum of squares, we need to tell it if we're going to pass something to it. So, and this will make more sense later on. So we're going to pass in the number that we want to return the sum of squares. And then instead of printing it, we're going to return it. Which basically means however we call this, again this will make sense in a second, it's going to send back what the sum is. So let's get rid of that. Let's just tell Python about it. Okay. So now, if we say sum of squares and pass it in 13, it's going to return 10. Likewise, if we do like 81, so that's 64 plus 1 equals 65, so that's working. All right. So now we want to do, so let's use our first example of 13, because we know that 13 worked, right? Yeah, because we'd have 1 squared plus 0 squared is 1. So 13 is a happy number. So what we want to do is we want to loop through the sum of squares over and over again. All right, so we want to create something called a while loop. So basically a while loop, well, it'll keep running until some true thing or some false thing is true. So we want to say while the number, I'll just call it n in this case, so we don't get confused with this one here. Actually, you know what? I'm going to replace this with n. I could actually use the same variable name in both locations, but I'm going to do this so it's not as confusing. So while the number does not equal, so this is kind of cool syntax, does not equal 1. So basically inside this loop, it's gonna run forever while number does not equal 1. And we will give it an escape path. So what do we want to do? So number does not equal 1. So in this case, number equals 13. Okay, and we're going to say number equals the sum of squares num. So let's think about what's going to happen here. So while the number does not equal 1, so we've initialized the number to 13. Okay, so while number does not equal 1, so does it equal 1? No, it doesn't, so it's going to run this. And then it's going to take sum of squares num. So we know that sum of squares the first time, sum of squares of 13 was 10. So then it's going to run again. So then it's going to take 10. And then run this, that's going to equal 1, so it's going to stick 1 in there, and then it will stop. So that's just for fun. Let's look at what number equals after each loop, shall we? 10, 1, aha, that works. Okay, now let's pick another number. Let's pick like 14. See what happens here. Ooh, okay. So we've got a problem, it's just going to run forever. So let's analyze these numbers. Let's see what's happening. So in Python, there's this cool little trick. If we say end equals, and then inside the string, I'm just putting a space. Like I don't have to put a space, but if I don't, it's going to print them like that, which is kind of useless. So let's put in a space. And I'm just going to stop this, just to kind of see what's happening. So I'm just studying these numbers. So 17, 50, 25. I'm just trying to look and see if there's any pattern in this. Okay, so I do see 42, 145, 89, 85, 85, 89. Okay, right there, 89. If we look at this, that repeats. 89, 145, 42, 20. 89, 145, 42, 20. That repeats. Okay, so I'm guessing that any unhappy number will exhibit this characteristic, this behavior, and it's not going to repeat it, or it is going to repeat rather. So we can use that. We can use that. So what I'm going to do is I'm going to create a list. So in Python, list processing is very powerful. In other languages, you might hear them called arrays, but in Python, we call them lists. So what should we call this? Nums found. Okay, and I'm going to initialize that to an empty list. So these brackets, square brackets, they're sometimes called, but properly they're just brackets. If there's nothing in it, it's an empty list. So instead of printing the number, what I want to do is I want to put the number inside that list and then do a check. So if the number I'm putting in there is already in there, then we know that it's an unhappy number. Okay, so let's start by doing a check. So if the number not in, this is very cool in Python, not in nums found, then let's put it in there. So nums found dot append, so that's the keyword here, append. What do we want to put in there? We want to put in the number. Okay, so let's talk about that again. So what's going to happen? So we're going to take the number, we're going to look to see if it's in nums found. And if it's not in nums found, so this is very English-like, eh? Not in, which makes Python kind of nice. If it's not in nums found, what do we want to do? We want to append it. Okay. Else, we can say print happy, because then it's a happy number. And if it's a happy number, then at that stage we want to break. We want to get out of there. So let me get rid of this print statement. We don't need that. Okay, so let's think about this for a second. So let's run 13. And yeah, you know what, just for fun, I still want to print what the number is. Oh, yeah. let's print this up here, right after we determine what it is. All right. Okay, let's run that, see what happens. Okay. So okay, that worked, but it didn't print happy. Why not? I think, oh, because it escaped. Yeah, so the moment it found that num equaled 1, then it just jumped out because of the while loop. So we need to put this somewhere else. Okay, so let's get rid of the else. And let's put print happy all the way outside the loop. That's going to print happy all the time, which we don't want. So we want this to be an if statement. So if the num, no, sum of squares num equals, that's how we designate a comparison in Python to see if it's equal. If the sum squares num equals 1, then we want to print happy. And notice I indent that. That's the key thing in Python, is indentation for something like an if loop or an if statement or a loop, while loop or for loop. Okay, let's see if that works now. So we get 10, 1, 0, happy. Yep, good. Okay, so this is useful. Now, what about the case where it's not? So if we do like 14, which we know is unhappy, it's just going to run like crazy, so that's no good. So we need an escape. So if the number is not in nums found, okay, so here this will be our escape. So if it is in there, what do we want to do? We want to break. And print not happy. Okay, let's try that again. That's the moment where it starts repeating. Okay, so that seems to be working. Now, let's clean this up a little bit. We don't need to print the number. Okay, not happy. And let's test that again with 13, which we knew was happy. Happy. Okay, so that's working. All right, so this is very useful. So let's now turn this into a function. So instead of having to do this all the time, changing the number, let's turn it into a function. And what do we want to call this? Let's call this function is happy. Okay, and we know that we're going to pass it a number. So let's indent all of this. So now the nice thing is this is callable. Okay, so I could say is happy. And I want to pass it the number, so let's pass it 13. Oh, is happy is not defined. That's because I forgot to run this. I have to tell Colab about it. Now this is kind of neat, is I can actually collapse that now. It's still there, but I can just get rid of that so we can concentrate on this right here. Okay, so print is happy 13, so we get this none. Ah, that's because we are not returning anything. All right, so we need to change this a little bit. So instead of printing not happy, we can return not happy or return. So that's the thing about functions in Python, is that they return things. They send information back. Okay, and let's try it again. I'll collapse that down. Happy. Let's try 14. not happy. Alright, that works. Okay, so let's walk through this again. So first we did sum of squares. So we created this function. We initialized a variable that we call sum. We initialized it to 0. Then what we do is we step through the individual characters. So we had to take n, which is initially an integer, and we need to convert it to a string to allow us to parse it or to iterate through the individual digits. And then we simply did some math. So we took each digit, converted it back to an integer so that we could do math to it. Then we squared it, and then we added it to the previous sum, and we just stepped through each digit. So when it was like 13, it was 1 squared plus 3 squared, and we returned the sum. Okay. Then we wrote this function called isHappy, which uses sum of squares. And so our logic was that if it's not happy, that it's going to reuse numbers. So the sum of squares is going to reoccur. So we created this empty list called numsFound, and our logic was to put the numbers in there, and if the number's repeated, in other words, if it's already in there, then it's not happy. So we have a while loop which will run until there's some way to escape it. So loop just runs over and over and over again. And we said while the number does not equal 1, because that's our definition of a happy number, is when it equals 1. The sum of the squares of the digits equals 1. So first thing we do is we take the sum of the squares of the number and we stick it back in num. So like 13, right? Then the subsequent sum of squares equals 10. Then the subsequent sum of squares equals 1. And we say if the number is not in numsFound, so numsFound initially is empty. So if it's not in there, what are we going to do? We're going to append it to numsFound. Otherwise, if it is in there, then we're going to return not happy. So we're going to send the string not happy back to where it got called from, like down here, okay? And then we need to break. Actually, we don't need break in there anymore, because once we return, it exits the function. Yeah, so that's going to keep going. Yeah. And then we have our little escape here for when it is happy. So we're just going to double check if the sum of the squares. Oh, actually, well, no, we can simplify this even more. Yeah. So in this case, if it's not happy, it's going to return that. And if it is happy, then it's going to escape this while loop. And then we can just return happy. So that makes it even simpler. So I'm just going to run this to let Colab know about it. We can test it out. 14, not happy. Test it out with 13. Happy. Okay. So we have it working. If you have any questions, pop them into the comments below, and I'll do my best to answer them. I do know that this isn't as efficient as it could be. There's other techniques. I could use something called list comprehension to simplify this, but for a beginner tutorial, I think this demonstrates it well. Okay, thanks so much.